You simply won't believe it. Sugar's impact on your body closely mirrors that of a stimulant drug. Mere moments after consumption, sugar prompts a surge of dopamine in your brain, compels your pancreas to release maximum insulin, overloads your liver, damages your blood vessels, and forces your kidneys to filter in an inflamed environment. All of this transpires even before you've savored the sweetness. In this video, we'll scrutinize each organ with scientific precision, yet in a clear and understandable manner, so you can grasp why excessive sugar is far more perilous than it appears. If sugary foods are a daily staple for you, this video is essential viewing before it's too late. The journey of sugar commences the instant you take your first bite. Surprisingly, absorption begins right there in your mouth. Within the oral cavity, the enzyme amylase, present in saliva, initiates the breakdown of starches into simpler sugars. For refined sugars like sucrose or glucose, the body doesn't even need to wait for the small intestine. A portion is directly absorbed through the mucous membrane in the mouth. While this amount is small, it's sufficient to promptly signal the brain and pancreas that sugar has entered the system. As you swallow, the sugar swiftly travels through the esophagus and into the stomach. Here's a fact many overlook. The stomach does not digest sugar. There are no enzymes here designed to process glucose or fructose. However, due to sugar's simple molecular structure and high solubility, it doesn't linger in the stomach for long. It almost immediately slips into the small intestine, creating a sugar wave that floods your bloodstream just minutes after eating. This rapid absorption is precisely what leads to a sudden blood sugar spike, a glucose surge. You might sense it, a slight increase in heart rate, a temporary boost in alertness, perhaps even a hint of euphoria. Yet beneath this lies a cascade of biological consequences. The body must react immediately to extract sugar from the bloodstream, and that's when the pancreas, liver, and brain are compelled into overdrive. And it all started with that single bite in your mouth. So, after bypassing the stomach, sugar encounters virtually no resistance. In the small intestine, specifically the jejunum, absorption occurs at an astonishing speed. This is where your body absorbs nearly all simple sugars, glucose, fructose, and galactose, through active transport and facilitated diffusion. For every spoonful of sugar you consume, the small intestine pushes an equivalent amount of glucose into the bloodstream almost instantly, especially if the sugar isn't coupled with fiber or protein, which would typically impede absorption. This sudden rise in blood glucose isn't just a normal variation, it's a mild metabolic shock. Within minutes, blood sugar can soar from a baseline of 90 milligrams per deciliter to over 140 to 160 milligrams per deciliter, depending on your digestion speed and the amount of sugar consumed. This phenomenon is known as a glucose spike, and your body cannot afford to disregard it. The pancreas immediately releases insulin, a hormone that acts as a key to transport glucose into cells. However, insulin doesn't simply channel sugar into muscles. If insulin levels are frequently and persistently elevated, it triggers a chain of side effects. Fat storage increases, and cells' sensitivity to insulin begins to wane, a condition termed insulin resistance. This lays the groundwork for significant metabolic issues such as prediabetes, type 2 diabetes, metabolic syndrome, and an increase in visceral fat. What's remarkable is that the small intestine is incredibly efficient, perhaps too efficient, at introducing sugar into your blood. And that efficiency, when misused by a high-sugar diet, transforms into a biological vulnerability. The digestive system was designed to process natural sugars from whole fruits, not refined sugars hidden in ultra-processed foods. And when glucose continuously floods in uncontrollably, the pancreas isn't the sole organ to suffer. The liver is next, and it will bear a substantial burden. As blood glucose levels surge after a meal, the body must act swiftly to restore internal equilibrium. The pancreas, a small gland situated behind the stomach, plays a crucial role at this juncture. It secretes insulin, a hormone that functions like a key, unlocking cell membranes to allow glucose entry, where it's either expended for energy or stored as glycogen. This system operates effectively when glucose enters the bloodstream at a steady, natural pace. However, when you ingest large quantities of sugar, particularly refined sugar and high glycemic carbohydrates, the pancreas is compelled to overexert itself, releasing insulin rapidly and in copious amounts. Initially, your body can cope, but if this occurs daily over months or years, cells begin to disregard insulin's signal. This condition is termed insulin resistance, and it represents one of the most perilous metabolic dysfunctions today. Insulin resistance doesn't appear overnight, but it progresses insidiously. Early indicators might include heightened sugar cravings, abdominal fat accumulation, post-meal fatigue, dark patches on the neck or underarms, and a slight elevation in blood pressure. Left unaddressed, this progresses to prediabetes and eventually type 2 diabetes, where the pancreas becomes exhausted from prolonged overwork. Yet the damage extends further. Chronically elevated insulin levels promote fat storage, particularly in the abdominal region, the type of visceral fat that fuels systemic inflammation, disrupts hormonal balance, and heightens the risk of heart disease, cancer, and fatty liver. Research also correlates elevated insulin with hormonal disorders, cognitive decline, and persistent weight gain. And while the pancreas struggles to keep pace, the liver, the primary processor of fructose, is entering its own crisis. Unlike glucose, fructose cannot be directly utilized by muscle cells. It heads straight to the liver, and what transpires there is far more hazardous than most people comprehend. While glucose can be directly used by almost every cell in the body, fructose cannot. Muscle cells, brain cells, and fat cells do not directly absorb fructose. Instead, every particle of fructose you consume, from sodas, fruit juice, corn syrup, to table sugar, must be processed exclusively by the liver. And this is where a silent crisis begins. The liver is equipped to handle small quantities of fructose from whole fruits, but when you consume excessive added sugar, especially from ultra-processed foods, the liver is forced to operate far beyond its natural capacity. When fructose intake exceeds processing capabilities, the liver begins converting the surplus into fat, particularly visceral fat, the dangerous type of fat that encases internal organs and isn't visible externally. This process leads to non-alcoholic fatty liver disease, NAFLD, which is now rapidly increasing worldwide, even among children. It represents the initial stage of a perilous metabolic cascade. Fat accumulates within liver cells, triggering low-grade chronic inflammation, and over time can advance to steatohepatitis, fibrosis, and even cirrhosis. Worse yet, a sugar-overloaded liver also produces more triglycerides and VLDL cholesterol, unhealthy blood fats that elevate the risk of atherosclerosis, hypertension, and cardiovascular disease. Studies also indicate that fatty liver is directly linked to insulin resistance, meaning the liver itself contributes to blood sugar dysfunction throughout the body. What's concerning is that early-stage fatty liver often exhibits no obvious symptoms. You may feel perfectly fine while your liver is already accumulating fat, experiencing inflammation, and its capacity is diminishing. And while the liver grapples with fructose, the brain is being affected by sugar in an entirely different manner through the dopamine system. While the liver contends with the physical repercussions of sugar, the brain is impacted in a completely distinct way, through the neural reward system centered around dopamine. This neurotransmitter is responsible for motivation, pleasure, focus, and habit formation. And here's the crucial point. Sugar, especially refined sugar, is a potent dopamine trigger. Within minutes of sugar consumption, dopamine levels surge in the brain's nucleus accumbens, the same pleasure and motivation center activated by certain drugs. This generates feelings of euphoria, alertness, and satisfaction, akin to the initial rush from addictive substances. That's why a bite of candy or cake can instantly elevate your mood. However, dopamine doesn't remain elevated for long. After peaking, it rapidly declines, leaving you feeling weary, sluggish, irritable, and unfocused. Herein lies the peril. To experience that high again, the brain begins to prompt you to seek more sugar, initiating a cycle of reward, crash, craving, known as the sugar addiction loop. Over time, if the brain is overly stimulated by sugar too frequently, the dopamine system starts to desensitize, meaning you require more sugar just to experience the same level of joy as before. This not only promotes overeating, but also impairs behavioral control, short-term memory, and attention. Studies demonstrate that prolonged high sugar intake is linked to reduced function in the hippocampus, a brain region vital for learning and memory. Furthermore, high sugar diets are associated with mood disorders and an increased risk of depression and anxiety. The irony is this: the very foods that provide immediate gratification are silently disrupting the system that governs your emotions and logical thinking. And while your brain is entwined in the dopamine loop, your blood vessels are beginning to suffer because high blood sugar doesn't solely affect hormones, it also erodes the physical architecture of your body from the inside out. When blood sugar levels remain consistently elevated, the body doesn't just face hormonal disruption, it also begins to sustain structural damage at the cellular level, particularly within the blood vessels. This is where a lesser-known but extremely dangerous process unfolds: glycation, the bonding of sugar with proteins. When glucose or fructose circulates in excess, it binds to various proteins and lipids within the body, creating detrimental compounds known as advanced glycation end products, or AGEs. These sugar-coated molecules resist elimination and can distort the inherent structure of connective tissues. Blood vessels, rich in collagen and elastin, are particularly vulnerable to damage from AGEs. As collagen stiffens and deforms, these vessels lose elasticity, becoming rigid and thick. This process escalates blood pressure, forcing the heart to work harder to circulate blood throughout the body. Furthermore, AGEs instigate prolonged inflammatory responses within vessel walls, resulting in chronic vascular inflammation. Over time, this leads to the formation of atherosclerotic plaques, where fats, cholesterol, and dead immune cells accumulate at damaged sites, narrowing and stiffening arteries. This sets the stage for severe cardiovascular incidents, including strokes, heart attacks, and cerebral embolisms. Many young adults consuming sugar-laden diets, appearing healthy, are unknowingly accumulating arterial plaque. A sustained glucose surge not only exhausts the pancreas, irritates the liver, or triggers mood swings, but it also erodes blood vessels from the inside out. The insidious nature of sugar is that it doesn't strike suddenly. Instead, it slowly corrodes with each seemingly innocent sweet treat. The body doesn't cry out in pain, but the damage is already occurring. As blood vessels weaken, the kidneys, essential for blood filtration, become the next organs in jeopardy. Once insulin temporarily manages blood sugar, any excess not converted into energy is stored as fat. This represents an ancient survival mechanism, allowing the body to reserve fuel for potential future scarcity. However, in contemporary life, characterized by abundant sugar and limited physical activity, this mechanism has become a primary driver of obesity and metabolic disorders. Persistently elevated insulin levels signal an energy surplus, prompting the body to enter a fat storage mode, transforming glucose into fat. This fat primarily accumulates in strategic areas, such as the abdomen and around vital organs like the liver, heart, and kidneys. This type of fat, known as visceral fat, differs from subcutaneous fat found beneath the skin. Visceral fat is a perilous internal storage depot. It doesn't merely occupy space or compress organs. It functions as a hormone-secreting tissue, releasing inflammatory cytokines like IL-6 and TNF-alpha and disrupting metabolic hormones such as leptin and adiponectin. The outcome is widespread chronic low-grade inflammation throughout the body, impaired appetite regulation, slowed fat burning, and a constant shift into storage mode. This explains why many individuals find weight loss increasingly challenging with repeated attempts, as insulin and visceral fat have already disrupted their internal energy regulation systems. Research indicates a direct link between visceral fat and insulin resistance, type 2 diabetes, cardiovascular disease, cancer, and cognitive decline. Alarmingly, one can appear lean yet possess high visceral fat, a condition termed TOFI, thin outside, fat inside. While abdominal fat is visible, visceral fat poses a silent threat. As this hidden fat accumulates, the kidneys, our blood-filtering organs, are forced to operate within an inflamed, hormone-disrupted, and toxin-laden environment. When blood sugar remains elevated over extended periods, the delicate microcapillaries within the kidneys are among the first to suffer damage. The kidneys operate as a filtration plant for blood, containing millions of microscopic units called nephrons. Each nephron functions as a highly precise coffee filter, retaining essential substances while eliminating toxins and waste through urine. However, continuous high blood sugar levels degrade the nephrons. Excess glucose impairs the endothelial lining of the capillaries, disrupting the intricate filtration process. This is akin to pouring too much sugar into a coffee filter. The fine pores become clogged, the output turns murky, and internal pressure builds. Over time, the nephrons become inflamed, scarred, and lose their capacity to function properly. One of the earliest indicators of sugar-related kidney impairment is the presence of albumin in the urine, a condition known as albuminuria. Normally, albumin is retained in the blood, but when the nephron's filter is compromised, it leaks through, much like coffee grounds escaping into your cup, signaling a damaged filter. Furthermore, kidneys affected by sugar are more prone to kidney stone formation, as excess sugar alters urinary calcium oxalate levels and pH. Reduced filtration capacity also leads to a buildup of toxins in the body, manifesting as fatigue, headaches, hypertension, and widespread metabolic disruption. As kidney function declines, it's not merely urine affected, the entire internal balance falters. The alarming aspect is that kidney damage often progresses silently in its initial stages, with no noticeable symptoms. By the time it is detected, a significant portion of filtration ability might already be lost. And when the liver, pancreas, blood vessels, brain, and kidneys are all compromised, what follows? The immune system, the body's ultimate defense, begins to weaken under the relentless assault of sugar. When the pancreas is overtaxed, the liver overloaded, blood vessels damaged, and kidneys impaired, one might believe the body has reached its limit. Yet, one final safeguard remains: the immune system. Unfortunately, sugar does not spare this last line of defense. Numerous studies demonstrate that merely 20 to 30 minutes after sugar intake, the capacity of white blood cells, particularly neutrophils, to eliminate pathogens can decrease by up to 40% for several hours. This occurs because elevated blood glucose interferes with phagocytosis, the process by which immune cells engulf and destroy bacteria, viruses, and fungi. Consider it this way. If immune soldiers could typically eliminate 10 invaders per hour, after a sugary drink or dessert, their efficiency drops to 6. When sugar is consumed frequently, day after day, this immune defense becomes chronically weakened, rendering the body more susceptible to inflammation, infection, and inexplicable fatigue. The immune system is not solely an army combating the flu. It deeply engages in various processes, including clearing damaged cells, detecting nascent cancers, and regulating inflammation throughout the body. However, when sugar induces chronic low-grade inflammation, the immune system is compelled to operate under constant stress, ultimately leading to systemic exhaustion. Moreover, sugar disrupts the gut microbiome, where 70 to 80% of the body's immune cells reside. An imbalance between beneficial and harmful bacteria disorients the immune system, making it more prone to misfire, triggering inflammation, allergies, or even autoimmune diseases. In essence, sugar does not merely harm a single organ. It unleashes a silent storm that propagates through every biological system, from energy and brain function to metabolism and immunity. This storm often begins with something as innocuous as bubble tea, a pastry, or a natural fruit juice. From a single slice of cake to a seemingly harmless can of soda, sugar doesn't just taste sweet, it triggers an intricate cascade of biological responses. If you've followed thus far, one truth should be clear. This isn't about a single sugar molecule. It's about a metabolic domino effect. Excessive sugar spikes glucose, triggers surplus insulin, encourages fat accumulation, especially visceral fat, leads to chronic inflammation, damages blood vessels, and eventually harms the liver, kidneys, heart, brain, and immune system. No organ is truly safe when the body is regularly inundated with sugar. However, remember this: your body doesn't despise sugar. It detests sugar overload. Glucose is vital fuel. Fructose from fruits is beneficial when consumed judiciously. The problem lies in the quantity, not the substance itself. Your biology simply wasn't designed to process 20 to 30 teaspoons of added sugar daily, yet many people unknowingly consume this amount. At this juncture, you have two choices: allow the domino effect to persist, or interrupt the chain and reverse it. The good news is that your body possesses remarkable self-healing capabilities. Within just a few days of reducing sugar, insulin levels begin to fall, visceral fat diminishes, the liver can rest, the brain stabilizes, the kidneys recover. Even your immune system, the ultimate line of defense, will rebound. And no, complete abstinence from sugar isn't required. You simply need